Hello there. Welcome back to Learner's Academy. Today we are going to learn how exponents and roots work in algebra. We've already have a fair idea of exponents and roots in arithmetic, but now it's time to learn the basics of how they're used in algebra. In the previous videos, we have learned that one of the main differences between arithmetic and algebra is that algebra involves unknown values and variables. In arithmetic, you might see 4 square, but in algebra, it's more like x square. And instead of the square root of 25, you'll find the square root of x. Sounds interesting, right? In algebra, one of the main goals is to uncover these unknown values, kind of like solving a puzzle. But before we go into the details, let's take a look at an important pattern in algebra that will make working with exponents way easier. It's the pattern formed by the expression x to the power n. Here x is called the base, and n is called the exponent. In this expression, x could be any number, but n can only be an integer, while n can be positive or negative integer. But to keep things simple here, we will consider non-negative integers. That means we will limit n to a set of numbers, 0, 1, 2, 3, and so on. If n is 0, then we say x to the power 0. If n is 1, then we have x to the power 1. If n is 2, then we have x is to the power 2, or x squared. If n is 3, then we have x to the power 3, or x cubed, and we could keep on going with this pattern. X to the power 4, x to the power 5, till x to the power infinity. So, what does these exponents mean? Let's start with something simple. When we say x squared, we're really just talking about multiplying x by itself. Or in other words, x multiplied by x. Easy, right? Now, if we come across x to the power 3 or x cubed, then just means we're multiplying x 3 times, or x multiplied by x multiplied by x. And if we keep increasing the exponent, we just keep multiplying more x together. But here's a question. What about x to the power of 1? If squaring means multiplying 2x, then does x to the first power mean multiplying 1x? That sounds a little strange, but actually it makes perfect sense. Multiplying 1x just gives us x. And that leads us to an important rule. Any number raised to the power of 1 is just itself. Pretty cool, right? This rule, or property, is similar to the identity property of multiplication that says any number multiplied by 1 is just itself. So x to the power 1 makes sense now. But what about x to the power 0? Does that mean no x's multiplied together? It seems like x to the power 0 should be 0, but it's actually 1. So how anything to the power 0 is 1? This is a special case and a bit tricky. Before knowing how x to the power 0 is 1, let's go through some basic but very important rules of arithmetic and algebra. First, remember, x to the power 1 is x, and x to the power minus 1 is 1 divided by x. Similarly, x to the power 2 is x squared, and x to the power minus 2 is 1 divided by x squared. This means x to the power minus n actually means 1 divided by x power n. Simple? Okay, the second rule says that if two numbers with same bases are multiplied, then their powers are added. For example, x power 2 multiplied by x power 3 can be written as x to the power whole, 2 plus 3, or in other words, x power 5. We can say that x to the power a multiplied by x to the power b is equal to x to the power whole, a plus b. Similarly, if two numbers are divided with same base, then their exponents are subtracted. Therefore, we can say in the following example that x power 3 divided by x power 2 means x to the power whole 3 minus 2, which gives us x power 1, or simply x. Or as a rule, we say x to the power a divided by x to the power b is equal to x to the power whole a minus b. So far, so good. Now, using these two basic rules, we write x to the power 0 as x power n minus n. After all, any number minus itself is 0, isn't it? Now, as we know that subtracting exponents of same base means the numbers are divided, Therefore, we write x to the power whole n minus n as x to the power n divided by x to the power n. Here, the numerator and denominator are same and cancel out each other, thus leaving us with 1. So, the golden rule is x power 0 is always 1. Now we know the logic behind it, therefore we can say confidently that any number power 0 is always 1. Let's focus on some basic algebraic equations involving exponents and roots. Let's start with this equation. The square root of x equals 4. Our goal is to find x, meaning we need to figure out its value without just guessing. So how do we do that? Well, remember that solving an equation means getting the unknown all by itself on one side of the equal sign. Now, at first glance, it might seem like x is already alone. There aren't any extra numbers hanging around with it. But there's one thing in the way: the square root symbol. To truly isolate x, we need to remove any numbers or operators by the unknown x. In this case, we need to isolate the x from the square root operator sign. But how do we do that? Now, here's something really important to remember. Exponents and roots are inverse operations. That means they undo each other. If we want to get rid of an exponent, we use a root. And if we want to get rid of a root, we use an exponent. So, in our equation, to undo the second root, or square root, of x, we're going to need to raise it to the power 2 or square it. If we square the square root of x, those operations will cancel out, and we'll be left with just x. Okay, so we can undo the square root by squaring that side of the equation, but remember, to keep our equation in balance, we need to do the same thing to both sides. So we need to square the 4 also. 4 squared means 4 times 4, which is 16. By squaring both sides of the equation, we changed it into x equals 16. We solved for x. That was pretty easy. Let's solve another root equation, but this time it's a cube root of x equals 4. Just like before, our goal is to get x all by itself. But since we're dealing with a cube root, squaring both sides won't help. Instead, we need to use the exponent that matches the root. That means square roots are undone by squaring, raising to the second power. Cube roots are undone by cubing, raising to the third power. Similarly, fourth roots are undone by raising to the fourth power, and so on. So, to solve this equation, we cube both sides. On the first side, the operations cancel, leaving x all by itself. And on the other side, we have 4 to the power 3, which is 64. So, our final answer is x equals 64. And that's it. Another equation solved. Easy, right? Now, what if we have an equation with an exponent instead of a root? Let's take a look at this one. X squared equals 36. Again, we need to get the x all by itself, which means we need to deal with the exponent on this side of the equation. How do we undo an exponent? Yes, you figured it right. We use a root. Since the x is being squared, if we take the square root of x squared, the operations will cancel out, leaving x all by itself. And on the other side, we have the square root of 36, which is 6. So, the answer to this problem is x equals 6. Well, that's half of the answer anyway. This problem is actually a little trickier than it looks, and that's because of negative numbers. Remember when we talked about multiplying integers? We learned that a negative times a negative gives us a positive. And that's super important when it comes to roots, because it means there can be more than one answer. For example, we already know that 6 times 6 equals 36. But because of that rule about negatives, we also know that negative 6 times negative 6 equals 36. That means the square root of 36 could be either 6 or negative 6. So, which one is correct? Here, both plus 6 and minus 6 are the correct answers. In algebra, when we know an answer could be positive or negative, we use a special symbol. x equals plus or minus 6. This plus or minus sign tells us that x could be either value. You could substitute either value in x in the equation, and it would make the equation true. We use this whenever we find even roots of a number, since the answer can be both positive and negative. And just like that, we've solved the equation. So far, we've seen that even roots, like square roots, can have two solutions, one positive and one negative. But what about odd roots, like cube roots? Let's find out. Take this equation. X cubed equals 27. To solve for x, we need to undo the cube by taking the cube root of both sides. Cube root of x to the power 3 equals cube root of 27. On the left side, the cube root cancels the 3 in the exponent, leaving just x. On the right side, we need to figure out the cube root of 27. If we think about factors, or use a calculator, we find cube root of 27 is 3, because 3 times 3 times 3 is 27. So in this equation, x equals 3. But what about negative numbers? Is x equals negative 3 also a valid solution to this equation? Nope. And here's the reason. If you multiply negative 3 times negative 3, the answer would be negative 27. So the cube root of 27 is 3, but not negative 3. In this case, there's only one solution. All right, in this video, we learned two important rules about exponents. We learned that any number raised to the power 0 equals 1, and that any number raised to the power 1 is just itself. We also learned how to solve very simple one-step equations involving exponents and roots. Since they are inverse operations, to undo a root, you use its corresponding exponent, and to undo an exponent, you use its corresponding root. For even roots, like square roots, we have two solutions, positive and negative. For odd roots, like cube roots, we have only one solution, either positive or negative, depending on the number. There's a lot more to learn about exponents in algebra, but those are the basics, and to make sure you practice by doing some exercise problems. Thanks for learning with us today. If you found this helpful, don't forget to like, subscribe, and hit the bell icon so you never miss a lesson.